Hello students, this is lesson U3A00. By the end of the lesson, you should be able to say I can find area and perimeter of triangles and categorize triangles. So let's take a look how we can classify different types of triangles. So we can certainly classify triangles based on their angle measures. And the way in which we classify triangles based on their angle measures is if the triangle happens to have an obtuse angle. If it has an obtuse angle, and obtuse angle is an angle that's greater than 90, then we refer to this triangle as being an obtuse triangle. If all the angles inside of a triangle are less than 90, then this is referred to as an acute triangle because all the angles are acute. If there is at least one angle inside of the triangle that is a 90-degree angle or a right angle, then this is referred to as a right triangle. Similarly, we can classify triangles based on their side lengths, okay? So a triangle with all the sides the same, we refer to that as a equilateral triangle. If there are two sides within a triangle that are the same, we would classify that as an isosceles triangle. If there are all three sides that are different, we refer to that as a scalene triangle. To find the area of a triangle, we need to know what is the length of the base, and we need to multiply that by the height. And depending upon what the circumstances are, okay, whether or not we have an obtuse, acute, or a right triangle, the formula is all the same. The only thing is sometimes recognizing what is the base and what is the height can tend to be a little tricky, especially in this case right here. The length of the base, okay, is only the length of the side of the triangle. Now the height of the triangle is a line drawn from the very tip of the triangle down to the base. And the formula remains the same if you recognize that as being a fact. However, having said this, okay, we're in this lesson, you will be asked to find out what the area of the triangles are. However, it will be far easier to not use this formula, but to use another technique, which I am about to explain. All right, so what we have here, okay, are three different problems, okay, and for each of these, we need to identify the type of triangle formed, whether or not it's isosceles, equilateral, or scalene, and then we need to find out what the area is, okay? So let's take a look at the first example here. Please take a moment, grab a sheet of graph paper, and I need you to plot points A, B, and C onto a sheet of graph paper, onto a coordinate grid. So upon inspection right now, just looking at it, okay, this triangle looks to be isosceles, just looking at it, okay? However, in order for us, because this is actually technically classified as a coordinate proof, you need to show why this is, in fact, a isosceles triangle. So in order to do that, we need to find out the length of all three sides of this triangle, and we need to go through this systematically. You can use one of two things. You can use Pythagorean theorem, or you may use the distance formula, whichever one is to your liking, okay? I will use the distance formula. So going from A to B, okay, this length right here, AB will have a length of 2. If I go through and find out what is the length of AC, I recognize I'm going to go up 2 and over 1. So the length of AC is going to be the square root of, what is that? It's going to be 2 squared plus 1 squared, or it's going to be square root of 5. Similarly, we're going to go from B to C. We go up 2 and over 1. So the length of BC is going to be square root of 5 once again. Okay, so the length of BC is going to be square root of 5. We need to find out what is the area of this thing, right? So the best thing to do, okay, I'm going to show you another technique rather than using the area of a triangle formula. What we can do is we can find out what is the area of this box. The area of the box is 2 by 2, which is 4. And then the area of not the triangle, but the area of the triangles that surround it. You may think to yourself, like, this looks like an overly complicated process, but believe me, this process proves to be useful again and again and again. So the triangle here, okay, to the left and right, if you notice that the base and height, it's 1/2 base, which is 1, times 2. So the area is actually 1. So really, I'm subtracting 4 by, so the area of triangle ABC is equal to 4 minus 1 minus 1, which is going to equal to 2. So the area turns out to be 2. All right, so now let's take a look at the next example here where we have triangle XYZ. So triangle XYZ, okay, looks like this. And again, we need to figure out what kind of triangle it is, whether or not it's scalene, isosceles, or equilateral. Just by inspection here, we can already kind of tell if you're a visual person that this triangle is in fact a scalene triangle. But we need to prove that, okay? So again, we're going to use the Pythagorean theorem here. XZ, we are going to go up 2 and over 1. What that means is this is going to be square root of 2 squared plus 1 squared, and that is square root of 5. We're going to go and figure out what YZ is. So to find out what YZ is, we're going to go over 3 and down 4. So to do that, this is going to be square root of 3 squared plus 4 squared, and this turns out to be square root of 25, which then turns out to be 5. And then lastly, we're going to figure out what is the length of XY. The length of XY, we go down 2 and over 4. So that is the square root of 2 squared plus 4 squared, and that is the square root of 20. And this reduces to 2 square root of 5. And yes, all three sides are different. So triangle XYZ is scalene. All right, so now what we need to do is we got to figure out what is the area of the triangle. So like I said before in the previous example, we're going to find the area of the surrounding triangles that surround the given triangle here, and then we're going to subtract from the overall box. If you notice now, the overall box has dimensions of 4 by 4, which is 16. All right, so now we're going to find the area of this triangle. I'm going to use a different color because they're overlapping and it's hard to see, so I'm going to use red. So the area of that triangle over here, it's 1/2 2 times 1, or the area is 1. I want to do and find out what the area of this guy is. It's 1/2 3 times 4. 1/2 of 3 times 4 turns out to be 6. And then the area of this guy, it's 1/2 of 2 times 4, which is going to be 4. So if I find the area of triangle XYZ, this will turn into 16 minus 1 minus 6 minus 4. So this is going to be 16 minus 11, or really it's 5. The area of the triangle is 5. Alrighty. We're going to find the area, what this is now. So looking at this, okay, I have triangle PQR. In this case here, it looks like it's equilateral, but it really isn't. So those of you who are visual can see that. Those of you who are not so visual, it's okay. We're going to try and prove this using a little bit of algebra. So we're going to find out what PR is. The length of PR, we're going to go up 2 and over 1. So immediately this is going to be the square root of 5 because it's 2 squared plus 1 squared. We're going to go over 3 and down 1. So our Q will be square root of 10. And then PQ, we're going to go over 4 and up 1. So PQ will be 4 squared plus 1 squared. And this is going to be square root of 17. So this is going to be scalene again. Triangle PQR is scalene because all the sides are different. Now we're going to try and find out what all these areas are, and then subtract it from the overall box. So check this out. The area of the overall box it's 2 by 4. The overall box is 8. So now I'm going to go and try and find out what is the area of each of these triangles here. So this has an area of 1. This has an area of 3 halves because it's 1/2 of 3 times 1. So it's 3 over 2. And then this guy here has an area of 2 because it's 4 times 1 divided by 2. So the area of triangle PQR will be 8 minus 1 minus 3 over 2 minus 2. And if you're wondering, like, what are you going to do with the 3 over 2, it's okay. You can call it 1.5 if you'd like, okay? So it really is 1 minus 1.5, 8 minus 1 minus 1.5 minus 2. Or in other words, 8 minus 4.5. And 8 minus 4.5, that's 3.5. The area of the triangle is 3.5. 3.5, or otherwise known as 7/2. It's the same thing.